The software development lifecycle is now transforming into the AI SDLC. Now we're calling it the AI software development lifecycle. So in this video, I'm just going to break down each phase within the software development lifecycle. And then in the next videos, I'm going to explain how we can use AI within each individual phase. There are 7 phases that you have to know as a software developer or as a vibe coder, vibe engineer, or someone that is looking to get into software development. Everything starts with the planning and the analysis phase. This is where the business comes in and starts to scope out the project. And this planning can be done in program increments, meaning that in a year or 5 years, they're planning for the next 5 years, or maybe you're planning just for a single year or 6 months. But traditionally, we plan in increments, in quarters. That's why businesses release their earnings every quarter, and there's 4 quarters in the year. So traditionally, we would have a program increment where we plan what we're going to deliver, and that could be between 3 to 4 months. This is where the business comes in. The stakeholders, the business analysts, even third-party vendors, they'll come and collaborate and think about what they want to build a roadmap, and within these activities, prepare high-level requirements, product requirement documentation, identify risks, identify trade-offs between one technology or another technology, or one feature or a different feature based on the business value. And most importantly, does it return a high ROI? Is it a good return on investment? And also in the planning phase, they analyze competition. What are the competitors doing and how can the business do better? This is where artifacts, business requirement documentation, meeting notes are created. And documentation is in general just created at a high level so that it can be fed into the next phase, which is the design and architecture phase. And this phase, this is where the solution architects, lead developers, tech leaders, and the business come together to prepare high-level technical design architecture documentation. They begin designing the architecture on whether it's going to be developed and built on the cloud or on-premise, meaning that the company is going to use its own infrastructure. But in 2025 and beyond, most companies are transitioning into the cloud using AWS, Google Cloud, or Azure. So in this design and architecture phase, the solution architects and the tech leads create something called technical design documentation, flow diagrams, visual technical design, entity database diagrams, and other visual diagrams that can help communicate to the business what's being built and why it's being built, and also determining the costs. So in summary, in this design and architecture phase, we gather documentation, but at a high level and more technical. Within the planning and analysis phase, design and architecture phase, we would create something called epics. Inside these epics, we would have user stories, tasks, and subtasks. That information is given to the development team and the QA team so they can understand and ask questions to determine how they're going to approach the development and testing for these new features. Once the planning and analysis phase and the design and architecture phase is completed, we move on to the development phase. And this is where the actual coding happens. So within the development phase, we have something called sprints, and we use agile methodologies. So for a given program increment for 3 to 4 months, we want to deliver something. And we choose some epics and user stories that we want to execute on. And then we break this down into sprints. It's a 2-week increment. So we choose a certain amount of work that we want to complete within a 2-week time frame. So we'll be doing the development and the testing, and hopefully the deployment as well. The development for a feature might take between 2 to 3 sprints before we even deploy it. So within these sprints, the development team are going to be doing the development. And in parallel of the development from the developers, the QA team, the test automation team, are preparing test plans, test automation strategies, asking questions with the developers and collaborating with the product owners to prepare test plans, test cases, and test strategies and documentation, how they're going to approach the testing once the development team is done. So after development, we go to QA and testing. So there's quality gates that have to be set so that whatever the developers have built, it needs to be tested. So once a developer completed their development and their unit testing, they'll deploy it to a test environment. It may be ready in the development environment for a QA engineer or a test automation engineer to begin testing. The QA engineer would execute their tests based on their test plan, which is based and mapped on the requirements. So whatever the requirements were, the QA engineer needs to build test cases that are going to satisfy that requirement. Therefore, the QA engineer will either run manual tests or have prepared automated tests to ensure that the development work satisfies the requirements. And once the development is done and the QA testing is done, a demo is presented to the product owner to ensure that whatever is built is approved by the product owner. And when it's approved to product owner, that feature is promoted to a higher test environment. And that's where we go into performance testing. So once functional testing is completed, we do something called non-functional testing. And one of those is performance testing. All right, so once the functional testing is done and we know the feature works as expected, we move to the performance testing. So just because your app works, it doesn't mean it can handle the pressure. And what I mean by this is you can have 10 or 20 users using the app at the same time, but it's a whole different ballgame when you have 100,000 to millions of users hitting the app at the same time. Performance testing is all about making sure that the system doesn't crash when the traffic increases. So in a traditional setup, most companies will have something called site reliability engineers working alongside with the business and the solution architects to set the expectations on how the performance expectation should be. Together, they define how much load the system needs to handle, whether it needs to be 100 users, 10,000 users, or millions of users. This is also where the concept words service level agreements and service level objectives come into play. The performance team validates that the application can meet those targets. The app needs to be 99.9% uptime. Response times need to be under 200 milliseconds during peak load with 500 requests per second. This ensures that the business can confidently commit to deliver positive, happy experiences to the customers while they're using the application.
All right, so once the performance testing is complete and has successfully passed the service level agreements and service level objectives, we can move on to the next phase, which is deployment and monitoring. This is when software or the new goes live. We take everything that was built and tested and pushed into the production environment so customers can start using it. Now, traditionally, deployments are handled through the called pipelines, continuous integration, continuous delivery. These pipelines automate a lot of work, but they still need oversight. That's where DevOps engineers and release managers come and decide whether to use a canary release, a blue-green deployment strategy, a feature flag configuration, or a full rollout, depending on the risk level of the release. But here's the most important part. Deployment doesn't stop once the code goes live to production. We have to monitor the application and scan through the logs and alerts to identify if there are any errors. This is where the team watches the system really close in real time. So site reliability engineers, DevOps engineers, and even the business pay attention to metrics, uptime, latency, error rates, and the system health across all the services. Monitoring is all about catching issues before they become outages or when the users start to experience the errors. If the spike in errors happens, there are going to be alerts in place so we can inspect the logs and the dashboards to trace what went wrong. Was it a code bug? Was it a configuration issue, a permission issue? Or maybe that couldn't scale properly. The faster you can fix it. That means less money spent. So the goal is very simple. Deployment delivers the product reliably, ensure that the app stays healthy.
All right, now the final phase, the feedback and iteration phase in the app. The business begins to analyze what features love and don't love based on the monitoring and customer feedback we can see in the logs, feedback reports, crash reports, performance metrics, and all the different types of feedback. Every bit of information becomes valuable insight to improve and grow. So the business will seek to collect data like surveys, customer interviews, public reviews, complaints, because the business will take this information and decide what to prioritize into the next release. This phase, the goal is simple. Take what's happening in production and feed it back into the cycle. If a feature is not working as intended, we analyze why. If customers are asking for feature enhancements, we capture those as new requirements. And if problems keep arising and showing up in the logs, we got to figure out how to fix it so it doesn't come back. This is how iteration happens. We build on top of what's already there, refining features, fixing pain points, or sometimes even creating new functionality based on what we've learned. And once that plan is clear, the loop starts again. We go back to the planning and analysis phase. So the big picture is this: the feedback and iteration makes the software development lifecycle a living, breathing cycle. It's not just about building once and walking away. It's about constantly improving, learning from real users, and making the product better every single release. And that's the full software development lifecycle. I hope you guys really enjoyed this video. I really wanted to talk about this topic because I feel like it's not talked about a lot because they don't see the full big picture. And I see a lot of vibe coders out there that are missing the most important pieces when trying to build a full scale application. So in future videos, I really want to dig into each phase and incorporate how AI can help within each phase. I'll see you guys next time.